All right. Hello, hello, hello. It's been a while since I've done one of these, but I'm about to do a chemistry video. I'm going to be doing question 1 from tonight's homework. At what Kelvin temperature will a sample of gas occupy 12 liters with a pressure of 2.7 atmospheres if the same sample initially occupies 8 liters at 27 degrees Celsius with a pressure of 4.5 atmospheres? Cheated a little bit. Hey, that's a 5-minute bell. It's 3:45. Cheated a little bit. Made my table ahead of time. Saved some time. My 1, I will be using red for, and my 2s, I will be using blue for. Okay, let's read this. We got some numbers. Initially occupies, so I know this is going to be my initial, this is going to be my initial, and this is going to be my initial. So I can put those in. 8 liters of 4.5 atmospheres and 27 degrees Celsius. Remember, temperature always needs to be in Kelvin. If I didn't explain this in class to you or you weren't paying attention, I can explain this. I'll explain why later, but you need your temperature to be in Kelvin. So 27 degrees Celsius in the Kelvin, you add 273. 273 plus 27 is 300 Kelvin. So I'm going to put that down here, 300 Kelvin. Okay? Cool. That means my final volume is 12 liters and my final pressure is 2.7 atmospheres. And I'm trying to find this temperature, T2. Okay? Let's see, what marker would be the best one? Let's use this one. Okay? So I got the things that I want and one thing that I'm trying to find. Okay? Let's set up, this is definitely not the right marker to use. Our formula, P1 times V1 over T1 equals P2 V2 over T2. I've shown you a couple different ways how to do this. We're trying to isolate T2. T2, that's what we're trying to get by itself, right? We want it by itself. We also want it to be in the numerator. If it's in the denominator, that's flipped around what we want. You get a different number than what you want. So we want T2 in the numerator by itself. Now, Ms. James showed me a little trick, okay? She says it's something you guys have been doing, allegedly. And you guys know of it as cross multiplication, cross multiplying. So this is what I'm going to do. I'm going to multiply these together, and I'm going to multiply these together. That should give me T2 times P1 times V1 equals T1 times P2 times V2. Can you see that? Is that too far off screen? Nah, perfect. Okay? Great, so now we got these on top. We got T2 on top. We just need to get P1 and V1 over to the other side. Okay? Right now, these are all multiplied together. That means to get rid of it, we need to divide it by the thing that we want to get rid of, right? So, and we need to divide both sides. If I divide this side by P1 and V1, and I divide this side by P1 and V1, now these will cancel out, and what we have is T2 equals T1 times P2 times V2 over P1 times V1. Now I can put my numbers in, okay? T1 is 300 Kelvin times P2 is 2.7 atmospheres times V2 is 12 liters. If you can't hear the next part of the video, it's because you guys are too loud in the hallway. Okay? Over P1, 4.5 atmospheres, times, I was tough, 8 liters. Remember your brackets, remember your parentheses. I call them brackets, you guys all make fun of me for it. If you do this, you should have an answer of 270 Kelvin as your final temperature. 270 Kelvin, okay? You guys are going to be shocked to hear. You got to do one more thing with this answer, and it has to do with significant figures, right? If you look back to what we started with, both of these only have one significant figure, so our final answer here needs to have one significant figure. May seem counterintuitive to change it to the correct answer after that, but if you did this on your calculator and this is what you got, great, fantastic. You're doing the right things. We can get the next step about sig figs in a bit. I'm trying to push my classes real hard for it. Number 2, I'm not going to do it up here, but I am going to give you a little bit of a hint, okay? If the pressure of a sample is halved and the temperature is tripled, what will happen to the volume? Remember your relationships. If pressure is halved, if pressure decreases, volume should increase, right? Because they're inversely proportional. So if pressure is halved, it goes down by a factor of 2, it's halved. Volume will double, right? If you have the pressure that's pushing on it, the volume of it will double. So use that and also the temperature tripling to kind of see what you can come up with, okay? That's it for question number 1. Good luck with the rest of the homework. Have a good day. Bye.